Thanks for joining me this morning. My name's Rob, I'm the CTO at Hipster Whale. Just going to share some experiences and tips from our time working on Crossy Road Castle. So I hope you have something you can take away from this and find it useful. For those who don't know us, Hipster Whale was founded in 2014. And from left to right, this is Clara Reeves, our CEO, and Andy and Matt, our founders, and they created Crossy Road in 2014. And it started as a little 6-week experiment, and they're like, this is pretty good, like we might have something here, so we'll spend another 6 weeks on it. And 10 years later, next year, it's still going live, going strong. And when Apple Arcade launched, Apple approached us to expand the Crossy Road IP to Apple Arcade, and so we chose to do a platformer, a multiplayer platformer, and this is a quote from Clara about the game. So this is the first time we're bringing the original Crossy Road characters into a new game. As a mother and gamer, I wanted to play a game we could play across generations. So we really wanted some good family fun, wanted to capture that sort of like hanging around an arcade machine kind of vibe, or sit around the couch, bring your game controllers or your Apple TV or your iPhones or any device, any iOS device you had to play together. So here's a video from the game. Yeah, just add fast. Okay, so it was developed for Apple Arcade. It's an expansion of the Crossy Road IP. It's a twitchy platformer, and it's available for iOS, iPad, tvOS, and macOS. Touchscreen, controllers, keyboard, local, Wi-Fi, online multiplayer. Bit of a combinatorial explosion, and we developed it pretty quickly, so we didn't have a lot of time to we didn't have a lot of time to spare when we were working on it. Our plan was to develop more content over time, which we've now done. So we started with a single tower, and we just really wanted to nail that experience and polish that. And gee, it was the right approach. Like originally, we were talking about having multiple towers and all that sort of stuff. And I'm so glad we got to just focus on having one really nicely polished tower, and then a few years later now we've got 10 towers, and we just have been releasing towers like clockwork, and it's worked really, really well. This is the development team, or some of them. We've been growing. With the development team with Crossy Road Castle, it grew linearly. Like I checked the revision logs and all that sort of stuff to see what the graph was of like change list velocity and all that sort of stuff, and we really grew linearly over the course of 12 months. And so it started as a prototype with a single engineer, and it originally started as like a bubble style game, and just evolved, just playing it, iterating on it, and seeing where it took us. It was 1 to 5 engineers, so ramped up over time. 0 to 2 artists, 1 designer, 1 producer. And the development environment, we used Unity. It was a combination of macOS and Windows, so we don't really force the usage of one or the other at Hipster Whale. We sort of mix and match between Mac and Windows, and it sort of ensures that both are pretty healthy at all times. Visual Studio, Jenkins for our build automation, and builds continuously published to Crossy Castle-builds on Slack, so you can always just grab the latest build. So the focus of this talk is on the multiplayer development So we had some important design goals. So we wanted to make it as easy as possible to get into the game. So we didn't, well, I'll mention that shortly, but we tested with our kids and stuff as well to make sure that they knew how to do it without prompting or instruction. We didn't want them to know, didn't want people to know or care what a client or server was. It's really funny how when you're a gamer and you're around other gamers and stuff, there's all this tribal knowledge, and you just take for granted that someone knows what a server or a client is, or that conversation occurs where you're like, I'll host, I'll join. So we tested it with my daughter and Clara's son, and we're just play multiplayer. And they don't have those conversations. They're just trying to jump in. We use an arcade machine metaphor, so it's no accident that we've got, you can see there on the right, you've got 4 slots at the front. So we really wanted to evoke the feeling of an arcade machine. And so with the one of the design goals from a technical level was when you're playing single player, you're playing a one-player multiplayer game. So that made it a lot easier to develop our multiplayer game. We wanted to encourage cooperation and celebrate when your fellow players succeed. So I have a son who's a massive troll, and when we play Overcooked together, he just sets the kitchen on fire all the time, and then he's out for a round, and then we let him back in for a round. And it's actually really great as a family experience, this one. So I've got a now 4-year-old son, and if he dies, he's when you get to the end of a room, he still spawns and goes to the end of the room, and he's like, yeah, I win. Maximum flexibility. So there really is a great number of combinations you can play this game. So if you imagine that you've got 4 humans on one device, and then imagine you've got 4 devices that all could be different devices as well. So, 2 devices, 4 humans, not a problem. So mix and match. So when you're developing a multiplayer game, it really should inform your overall architecture. It's something you should think about up front. It shouldn't be considered a feature. It'd be a really grave mistake to just consider multiplayer a feature. Some things are so easy to do if planned from the start, and so difficult to do if added later. So that's one of the key takeaways, is that prior planning is really, really beneficial. So you also should incorporate real-world latencies into your design. So you really need to consider, the speed of light is actually kind of slow. For example, I think round-trip time from London to Melbourne is 80 millis or something. That's quite a lot of frames. And that's just pure speed of light. So you need that will occur, your lag will occur somewhere, and so you really need to think about where it actually occurs in your game design. So multiplayer should also be visible and accessible to everyone on the dev team all the time. So it shouldn't be someone in the corner who's slaving away on the multiplayer and putting in a heroic effort to unbreak the game all the time and make it functioning a multiplayer. It's just something that should be visible for everyone all the time. So it's being tested at all stages. So we wanted to get great living room co-op and across multiple devices, and so we created what we called Wi-Fi mode, which is just good old-fashioned LAN multiplayer. And so in the game, you just simply press scan Wi-Fi, and the available games in your house show up, and you just press a button, and there'll be a prompt to join the game. So then there's no need to understand concepts of server, client, or hosting. As I said, we tested with our kids during development, so there's a fair amount of iteration with that, just to make sure that they could just be past the device and just be able to jump in and play. We also, later in development, added Game Center mode. So we originally weren't intending on this to be an online game, and that's because it was a twitchy multiplayer game, but we did add Game Center mode late in development. So supported Game Center multiplayer, and it was requested late in development. We were concerned about the impact for a twitchy game over the internet. But one of the good things on the architectural side is we'd implemented an abstracted multiplayer driver interface, so that So there was just like interfaces like iConnection and iServer, iClient, and so we ended up being able to implement multiple network drivers without too much hassle. So we ended up shipping with 3 different drivers. So we had, the third one was the null mode. So we had a null mode that basically is like a shared memory buffer where it's just publishing to a memory buffer and consuming it that way. So it just allows you to have just that simple pseudo network layer. And so our approach to developing the game in a multiplayer was we had it so that you could run the multiplayer in a single process. So I've worked on many multiplayer games, and they've usually involved having multiple dev kits or multiple instances of your editor or multiple builds of the game, and it can be a real pain in the ass. And so, so we did this. We had this approach where we ran a multi-client game, and so we could run up to 4 clients in the editor simultaneously, and they still communicate over the network. So we have like 4 clients, and they're still communicating over the network even though they're in part of the same process. So it really doesn't make a difference one way or the other. But one of the benefits is it allows us to do step debugging across a networked game. And so even in single player, we basically have like a server running internally and a client running. And so this allows for a really good approximation of what it's like when you actually deploy the builds and run over a proper network. It's not a substitute for multiple devices, but most issues were actually caught here, which was really awesome. So it helped us find and fix issues really fast. So it made it really easy to develop and test, and minimised our surprises, and which increases the quality of the multiplayer. I'll show you a little demo. So this is the Unity editor, and okay, so this is the game, and at any stage we can add another client. So here's display 1, display 2, and so I just want a second copy of the game. I can control client 1, I can control client 2, just change character. And away I go, I can just play the game. So I can do that up to 4 clients. And so for anyone who's developed a multiplayer game the other way, like, it's a lot easier. And so it allows us to step debug in the same process and all that sort of stuff as well. There's some other nice features as well, which I'll talk about in upcoming slides. But while we're here, I can apply color tints to the clients, and I can smush them together into one view. I can set the latency, artificial latency, so I can actually see the lag viscerally. So it's really, really easy to catch problems really early, and it can really quite clearly see any flaws, any issues with replication, you know, if you jumped and the other player didn't, or whatever. So yeah, so that's basically the gist of it. And so the way we did that is we had a client manager. So every client was isolated. And so we just had this kind of like very small class, which was a client manager at the top. And it was responsible for the creation and destruction of clients. And so when you press 1, 2, 3, 4 on the keyboard, it would just like spawn a new client. And we had the ability to also test gracefully shutting down clients as well as kind of pulling the cord out on other clients as well. So that was really handy. So we could just sort of like shift number, alt number, or whatever, and it would just like do the equivalent of yanking the cord. And so that was really handy. And we could also test like the 4 clients, get 2 controllers on one client, a keyboard or whatever on another client, and just mix and match all those combinations. And that was super handy. So the client manager was responsible for creating and destroying clients. It also routes inputs to the appropriate clients. So the client manager knows what clients exist, and it knows what inputs are coming in, and there's a mechanism to route those. So based on how you spawn it, how you spawn each client, and which key you press or whatever, it will allow you to, basically just route input to different clients. So clients can be gracefully or forcefully terminated. So this allows us to test lost clients, because that's something that comes up a fair bit. So the game actually ships like this too. So this is not just some special mode or whatever. This actually ships like this. It's just that it's just a one-to-one correspondence. So client manager spawns the one and only client in the game. So that really helps us test the game as it is and as it ships. And so it's not some special mode with if-defs and all that sort of stuff. That's really just the same code base. So to achieve that isolation of clients, we don't allow singletons. So singletons, they're a bit of an anti-pattern in my opinion. Like, I've never met a singleton that I've not ended up hating later. I remember working on an AFL game in like 2003, and there was like one football on the field. It was like a reasonable assumption you have one football on the field, until the designer for the sequel wanted to have like a training mode where there's footballs everywhere all over the field. It's like, and it's just embarrassing as an engineer to have to explain how it's really complicated to have more than one ball in the game. Then you have to do some big refactor job. So they're just better to avoid, in my opinion. There are some exceptions, and if you speak to me after, I can talk about some techniques for how you would transition. There are some tricks you can use to transition a singleton-based code base to one that is not. So the ownership hierarchy is really clear as well. When you do make sure that object management is all in clean hierarchies. The network protocol was a reliable over UDP protocol. Engineers just derive each message from game message. We have custom serializers with simple reader-writer methods. So it was a very deliberate decision that I didn't want some auto magic serializer. So I really wanted the engineers to know about the bits and bytes, so they could know this is what the size of a packet is, this is how I write it, this is how I read it, and it's pretty straightforward. So everything is identified by GUID. Annotations for required delivery methods, so some packets you send reliable and they have to arrive on the other side, some don't need to. And then we had lag and jitter simulation, which I showed you in that demo as well. So we're able to simulate lag in the editor. That was super helpful. And so that's basically like the mean latency, because across the internet you won't get, you'll have lag, but it won't be consistent for every packet. So we also had a feature where we could add a jitter to those packets, so you could actually see an uneven distribution of packets when they arrive. So it was just some sort of bell curve around the mean. So if there are bugs in your syncing code, it's really visually obvious. And note too that this game's been in development ongoing since we launched as well, and so like we've got new people on the team, and by having those tools available to them and seeing them up front has been really helpful. So there's just classes of problems that just don't exist in our development that exist for many other games. So it means fewer surprises and disappointments in the builds. So now onto hiding latency. So the speed of light, as I mentioned, is actually kind of slow, especially when you've got a game that's really twitchy. So we have lots of moving platforms. So sending global coordinates would have our clients fall out of sync. So if we have a platform moving around and then we have some global position sent and there's some lag, you would see a player standing on a platform and they would be offset. So what we did is we send the platform ID and we send the local coordinates. So even if Alice sees something different to Bob and the platforms are in different locations, they'll still make sense for each of those clients. Here's just a little thing that I thought was super cool. So when we were working on the game, I discovered a service called Pusher Channels, and it's basically, imagine like a chat program or like Slack, but for bots. And instead of talking in plain English, they talk in JSON blobs. So it allows you to have any computers anywhere, any devices, basically talk on particular channels. It's such an enabling technology. So if you have some web tool that's profiling the game or graphing stuff, producing heat maps, any of that sort of stuff, you can basically just have just hook up the channels API, subscribe to some channel. They can be totally dynamically named and all that sort of stuff, and then you can get graphing in real time and all sorts of stuff. So we use that a fair bit, sometimes for less ropey kind of tools, and other times for just like, let's just bash something out and see what the problem here is. So it's just a nice simple publisher subscriber API. One of the things we did, there was a website called sequencediagram.org, and you can just in this simple plain text format generate sequence diagrams. And so using this with that, we were able to produce like real-time sequence diagrams across the 4 devices to see that the connection flow was matching up against what we expected. That was kind of cool. It's just really simple, but like really neat too. So it allowed us to do things like real-time performance graphs. So if you just get your favorite web rendering API or whatever and just render graphs. And so the good thing is it can just be turned on and off as well. And this stuff was compiled out in the shipped game, as we and Apple take privacy really seriously. So it allowed us to do aggregated visualizations, and so this is just where to find it. I just think it was really cool. So for the outcomes, so the game launched early 2020, and it turned out to be very fortuitous that we added the online multiplayer. So we weren't going to do that originally, and as we all know, we had the pandemic, and so it was, we were grateful that we added online multiplayer. So it's been among the top few arcade multiplayer titles since launch. So it's really just like we have newcomers come and go, and we sort of bubble around the top since Apple Arcade launched. We've released 10 towers and 4.5 stars on App Store. Seems to be, gets good reviews and stuff. And so to summarise, multiplayer is not an additional feature. So design single player as a subset of multiplayer, not multiplayer as an offshoot of single player. So don't just get the hero program to go, oh, add the multiplayer. Like it has to be architected from the ground up to be a multiplayer game. And if you do, you end up with a much, much better product, and you save a lot of pain. So also preserve the sanctity and the portability of your client. If you actually have this client that you can take anywhere, that itself is really enabling. So you can do things like multiple clients in the same process. You can create bot builds. You can have it run somewhere else. For unit tests, anything like that. So it's really, really important, I think, to preserve these layers of isolation or layers of abstraction. So just assume that you'll want more than one client, and assume you'll want to use it elsewhere. So beware of singletons and other traps. Plan ahead. It's really easy to do up front. It's like embarrassingly easy to do this stuff up front, but really, really hard to retrofit. So consider your development workflows. Like some things I've done in the past is I'll either write like the user manual or use cases. This is Bob. Bob wants to debug the multiplayer game. This is the buttons they'll click, even if the buttons don't exist yet or anything. It's just like, describing the steps that you'll actually perform and work towards designing flows around that rather than have it emerge accidentally. So writing use cases can help. And so multiplayer development can easily get very, very frustrating and ineffective. I've got the scars to prove it. And so just a little bit about some of the other stuff we're doing from here. So we've been putting a lot of effort into newer stuff. We've got like a cloud-based engine, so we have got containerized game servers, an isolated application engine, operating at scale in the cloud. We're using a whole pile of cloud services, specifically AWS at the moment. So we're using Elastic Container Service, Lambda, Redis, DynamoDB, S3, CloudFormation, and technologies like Node.js, TypeScript, C#. So just give you a bit of a taste for some of the stuff it's not like that you might not normally associate Hipster well with. There's a lot of cool stuff we work on behind the scenes. And the elephant in the room. So a little bit about achieving engine independence. So one of the things we would like to do, due to circumstances beyond our control, we'd like to achieve engine independence. So fortunately, we've done a fair bit of R&D in this along these lines as well. So I would recommend, if you are starting a game from scratch, I would recommend you separate your authoring, application, and presentation layers. So kind of like a hamburger, where the meat in the middle is your game code, it's your application layer, and so presentation on one extreme, and the content and data authoring on the other. So you could use two different engines, you could use the same engine, but for two different purposes. So you can separate the engine from the runtime. So we have an engine where we've got an application layer that uses no existing game engine, and you'll find depending on your game, right, a lot of games you'll find you don't really need a game engine for most of your code. Like, you can actually separate the presentation stuff from the actual logic of your game, and it gives you better control over it too, right? Like, why be at the mercy of some engine and have the behavior and the feel of the game emerge, and so it's just like, welded to that engine. You can separate it, and it's actually a good thing. So often in game logic, you really only need things like math classes, math collections. Maybe you've got an ECS system, maybe you've got networking, perhaps you've even got a physics engine, and so there's lots of great physics engines around too. So it allows you to get control over your game architecture. So it is a bit frustrating for me when we have game code that all of a sudden starts to just, .transform, .parent, whatever, and just hack the you design this nice architecture, and then it's just all too easy to just sort of like hack at your game using the existing practices of that game engine. So I think it's a good thing to have more control over that anyway. So presentation layer, you can develop your presentation layer completely independent of your game. So make your presentation layer have a unidirectional dependency on the game logic, so that the game logic just couldn't care less, like whether you've got an ASCII renderer or whatever renderer or engine you're using. And so we have a system where we can basically expose just events to the presentation layer. So we'll know when an object is spawned, when it's despawned, was active, deactivated. There'll be just an event like honk, and it's up to the presentation layer to interpret that as it wishes. So, and then there's also state variables. So each game object can basically say, hey, my revs per minute are like 9,000. And they're just hints for the presentation layer to either play particles, play sounds, drive the renderer whatever way they like. It's really cool too, because when you have an architecture like that, it allows you to do things like heat maps, visualizations, tools. And so it's a really enabling technology. And then your content layer can be considered separate. So whatever you use to author your game content can be just totally separate from the game runtime. So you can still author the content using your editor of choice. And it shouldn't dictate necessarily your choice of runtime. They are actually separate things. And so we are going to endeavour to embrace open formats as much as possible. There's some really interesting, it's really great now, like there's some cool formats available. There's like the Pixar USD format, Universal Scene Description. There's the Kronos group have one called GLTF that Blender supports, and Godot supports, and so it's really exciting to see that it's not just like OBJs anymore. It's like there are actually like file formats that do this bundling, and so we'll embrace those. And so ultimately we'll be able to target multiple game engines. So whether we want some web client, or whether we want like a bot client that just like plays in DOS, or whether we, use whatever engine we would like, we can do that. And that's it. How do I go? Oh, that was really quick. Sorry, that was... okay, we've got tons of time. Yeah, I guess we'll take questions. Pass the mic around for the recording.
Thank you for the talk. It's really good. My question is, I was interested if you could go into a bit more detail about how you showed the tool where you're overlaying the server and the client between their positions. I wasn't exactly sure how you achieved that, and I'm kind of interested to hear how you set that up.
So, it's embarrassingly simple. They all coexist in world space in different locations, and you just untick a box and they just no longer do, and they just exist in the same place.
Does that mean, sorry to yell, but does that mean they all exist at all times? So the objects are still there, they're just turned off?
Yeah. And then to follow up in relation to separating your presentation from your application layer as well, there's no reason why there has to be a one-to-one correspondence between render objects and your application level objects. So I think it's a really good practice to separate those things anyway. And if you do, it's so easy just to say, no, just turn it off and don't see it. But it just turns out that, yeah, we just have them running in different locations. And so one thing I didn't mention is that we have the good fortune of having a game that's just super lightweight and fast. So if you've got a more heavyweight game, you're pushing things on hardware that's, your target hardware is closer to your dev hardware, then you're going to have to start doing things like lotting. But I think generally speaking, most games can be lotted pretty well, CPU-wise anyway. So it's probably just a good practice to get in the habit of doing that anyway. But yeah, we can run 4 clients, not a problem. Yeah.
So you mentioned a reliable UDP layer. Did you use something off the shelf? Did you write a custom one?
No, we did. We used LeadGrin. And so LeadGrin for the Wi-Fi mode and Game Center, or GameKit for, it's actually a little bit hard to find good, reliable over UDP layers in C# these days, actually. So, yeah, we've been using Yojimbo more recently. So LeadGrin was really great for peer-to-peer. It doesn't really scale very well as the number of nodes increases, but it was great. It's been, I think it was shipped in Terraria and other games. So it's a great library, but it just has its limitations. Yeah. There's someone behind. Question.
Thanks for the talk, Robert.
Yeah, no worries.
I have 2 questions.
Yeah, we've got time. I also, if anyone does actually want to leave, I'm not going to hold you hostage. Just chat. No. What you could imagine, for example, is like the server becoming a bottleneck because everyone's sending its packets back to the server. It's a pretty simple game, so we never really hit those sort of limitations. The sort of technical constraints we had weren't on that. That said though, we have had some subsequent content added where some people were yet to appreciate the sort of how like packet size and number of packets sent per second can increase. And so I didn't do a good enough job providing tools to catch that stuff early on. We kind of took for granted that would all be fine. And so we've since added tools where we can actually see sort of like minimum mean max latencies on any given room. And so we have auto tests and stuff. We can produce big composite images of all the different rooms of the game. We can like color code them with, whether they're like, if they're red and they need to be looked at. And so we can just see big fat numbers on like frame rate, memory, network bandwidth. So yeah, usually it's just, you've done something a little bit naive or something, but otherwise it wasn't too much of a problem. But we have had little one-offs like that. Yeah.
Differences that you do.
Yeah, so I'm going to phone a friend right now. So that chap with the mohawk is our UI UX designer. I don't know if you'd like to answer that, James, and Thomas beside him, I'll dob him in as well. Do you want to grab the mic and just answer
that? Could you repeat the question, please? It was what differences between single player and multiplayer? Yes and no. I think like our big focus is, as it is multiplayer first, you kind of want to make sure the UX is like centered around that, and then because it's like for a flow, like a single player. Single player, try to make it multiplayer. You have like all these other factors that you have to consider. Pretty much like the same with like building the game outright, where it's like it's all these other different scenarios that you have to think of after the fact. Whereas if you start with multiplayer, then you're considering all of those and designing that with those in mind. And then when you go over to single player, it's more just like streamlining it and like cutting out the multiplayer aspects and then making any adjustments, as opposed to the other way around.
Yeah, it was one of the principles to make it so you felt like when you're playing single player that you're missing out on multiplayer. So that's why, that arcade metaphor and seeing the 4 slots. So it was really communicated very clearly that it's a multiplayer game first. And I think that would have helped with, take-up rates of multiplayer.
Thanks for the talk. I'm curious if you used any advanced lag compensation when you replicate traffic over the network, because assuming each client will have like a different latency when it comes to online multiplayer.
I mean, we definitely did all the usual stuff like dead reckoning. So dead reckoning is a term we use in networking. It comes from an old hunting term. So if you're like duck hunting or something, and you've got some duck line. I don't advocate duck hunting. I'm just, and so you want to shoot ahead of the target to intercept it, and so that's sort of analogous to when you're sending packets or you're receiving packets that have already been received that already like they're from the past, and so you want to project them forward in time sometimes. So often you'll do certain interpolation sort of techniques. You'll smooth out the curves and project ahead and all that sort of stuff. We did a lot of that fine-tuning of, using cubic splines and all sorts of different techniques to do the blending properly. Because yes, if you just send it some frequency and you just receive it and you just plot it, you'll get quite a jittery kind of representation, and so you want to like blend and interpolate those to smooth those things out. And you also can't take for granted that you're going to get every one of those at a nice 1/60th of a second interval. And so you have to try to hide those things. One of the things that was really fortunate about the game too is you actually kind of didn't care what the others were doing. So the focus, it was so twitchy and so demanding for the player that they're mostly looking at themselves anyway. And so that was, we sort of took advantage of that as well. But it actually was like we were stunned with how robust it was over the internet. It works really well. have other Hipster Whale folks here too, so this could grow to just ask Hipster Whale about Crossy Road Castle.
Could you talk about more on how you were able to remove singletons from your game? How you were able to like reference
yeah, why not? Yep, we've got time now. So basically, one of the tricks we used was to take advantage of the parent hierarchy. And so if you have some singleton, instead of having a static method, and you just change it from a static method to a normal method, and then basically just walks up the hierarchy until it finds the nearest instance of that singleton. So it allows us to actually have multiple singletons. Because imagine that client 1, client 2, client 3, client 4, they all have a thing manager. They can all just look up the parent chain until they hit thing manager, and it's their instance of a thing manager. So other things we did on, like when I was at ArenaNet on Guild Wars, we used thread local storage. With thread local storage, you can have per thread singletons and stuff like that. So there are different techniques, but that was the main one we used, was the sort of like having like pseudo singletons. So I prefer not to have them at all, but that was what we did. And that allows you to not have to change the calling code. Yeah. This could be really good or it could be really bad.
What you're describing there resembles dependency injection. Did you look at that as a possible solution for the problem?
Yeah, that's how I tend to prefer things. I prefer to have interfaces passed into child objects and have the children not implement those interfaces, but use those interfaces, and so then it's up to the parent to implement the concrete implementation however they like. That's a general pattern that I prefer, but it's not always my code. And I should be really good at these like retrospective sort of things, because it's the sort of thing I ask in interviews and stuff as well. I guess we were a bit loosey-goosey with the metrics, with the like bandwidth and stuff. So there was a lot of unnecessary pain we could have avoided by implementing some of those systems earlier. We had a lot of time constraints, as you are well aware, and so we had to prioritize. And so if I could have waved my magic wand and done those things, it would have been great to have had better control over those things earlier on. There's still features I would like to have in the game that I won't elaborate on. I think generally it went pretty well, though. I'm pretty happy we met our overall objectives, and the lessons were learnt from prior games I worked on, really.
Thanks, Rob. Just a quick question about any tools you use to do performance metrics, like diagnosing performance problems, code plots, that kind of thing.
Yeah, so obviously we use all the tools available in Unity. We use its performance profiler. We use the GPU profiler, the CPU memory profilers. We will use all the suite of tools available in instruments on macOS. We will use things like that pusher channels to write ad hoc solutions, where we just basically like publishing, you want to subscribe to know about FPS, and so streaming FPS at some interval, plotting it on a graph. One of the things I did during development was just graphing of. I didn't really realize or appreciate how unreliable Wi-Fi is versus a cabled connection as well. Like, you can just get like black spots of like 70, 80, 100 millis, where the router's just choosing to not send those packets to your device during that time. And so there's a lot of like graphing and seeing where we've got. But a lot of the time it doesn't really persist. You just like write something, you solve a problem, and then you move on, because you don't have time to write the most beautiful tool for it or whatever. But that pusher channels was a really enabling technology for that. It really gave us the ability to look at what was going on a device, even where it's somewhere else. And then we use, for server instances and stuff, we'll use tools like Datadog, and so it all really depends. We just use all the things we can get our hands on, really. Yeah. But it is important to measure. Like, it's really, really important to measure and not guess. Yeah.
What considerations did What considerations did you have, like, for network security or validation of clients over the network?
That's not really a problem that we solve in Crossy Road Castle. So there's a lot to speak about that, and it all depends on the game that you're creating. So if you've got a MOBA or something where it's server authoritative, and it's really, really important that you have anti-cheating measures and stuff. You really want to have all the logic executing on the server, and you want the clients to just send up hints about what they're up to, and then have the server be responsible for all the secret source of. So you have code that some code can exist on the server, some code exists on the client, and so depending on essentially the requirements of your game, you might then loosen how authoritative that is for the purposes of just making it an enjoyable game experience. So in Crossy Road Castle, it wasn't a consideration. Please don't hack our game. It's been really nice. People have been quite lovely, and people are enjoying it and having fun. Don't ruin that for everyone, please. The consequences aren't that high in the game. You know, you're not like using real money transactions and this and that and the other. So it was a deliberate decision. All right, well, I guess that's it. But yeah, feel free to come and chat one-on-one. I'll hang around and enjoy the rest of your GCAP.